Our next 3 lessons will be on quadratic functions. We're starting off looking at quadratic functions in vertex form, which should look familiar after our transformation unit. We might have a stretch or compression, a horizontal shift, and a vertical shift. Whereas in the transformation unit, we had a critical point. We are now calling that the vertex. Our essential question is, how do I graph and write quadratic functions in vertex form? Starting off with our first example, you do have 2 choices. If you were comfortable with transformations, feel free to continue using that method. If you would like to see something different, that's what I'll show you in this video. First of all, identify if the parabola opens up or down. If there is a vertical reflection, the parabola will be flipped vertically and open down instead of, like the parent function, opening up. In this case, we have a negative not grouped with the x, so that is a vertical reflection, so our parabola will open down. The vertex you identify from the shift, we went right 4, up 5. Remember that x coordinate is with the x in the asylum, so it's not normal. The axis of symmetry is a vertical line across which the parabola can be reflected. It is symmetric across that line, and that goes through the vertex. So the vertical line that goes through the vertex would be an x equals equation, and it equals the x coordinate of the vertex. All right, so another way to graph quadratic functions is once you have that vertex identified, you choose 2 points smaller than the x coordinate of the vertex, 2 points larger than the x coordinate of the vertex, and sub them into the equation. I'm going to show a little bit of work here. So we're subbing 2 into our equation for x. Order of operations, we will first subtract the 4 to get -2, square it to get +4, multiply by a negative to get -4, and add 5 to get 1. Doing the same thing with the other numbers. If I substitute 3 into the function, 3 minus 4 is -1, squared is +1, times a negative is -1, plus 5 is 4. If I sub 5 in, 5 minus 4 is 1, squared is 1, times -1 is -1, plus 5 is 4. And finally, if I sub 6 in, I would get 6 minus 4 is 2, squared is 4, times the negative is -4, plus 5 is 1. Notice when you look at the t-chart that the values on either side of the vertex are the same. This is what creates the symmetry in the parabola. So if your t-chart doesn't look symmetric, your graph won't look symmetric, so go back and find your error. From there, we simply plot our points. Connect them with a smooth curve. Remember, a parabola is a U shape, not a V shape, like the absolute value function is. Finally, identifying our domain and range. Domain for a quadratic function is all real numbers. Range, because of that square, is not all real numbers. So notice that the maximum value that our parabola reaches is 5. So our y values are less than or equal to 5. Taking a look at another example. This one doesn't look like it's in vertex form, but we could easily convert it to vertex form by throwing a 0 in there. The leading coefficient is positive, so our graph will open up. Our vertex is 0, -3. So the axis of symmetry will be x equals 0. Remember the x coordinate of your vertex. Putting that vertex right in the middle of our t-chart, 2 values smaller, 2 values larger, and then subbing those into the function. Starting with -2. -2 squared is 4, times 2 is 8, minus 3 is 5. Subbing in -1, -1 squared is 1, times 2 is 2, minus 3 is -1. The same thing will happen when we substitute +1, because once we square it, a negative and a positive give us the same answer. And the +2 will give us the same answer as the -2. Plotting those points. Thinking about transformations, this one had a vertical stretch of 2, so it's a bit skinnier than the parent function parabola is. Domain, all real numbers for all quadratic functions. Range, find that y-coordinate of the vertex. It will be greater than or equal to the y-coordinate of the vertex if your graph opens up, and it will be less than or equal to the y-coordinate of your vertex if your graph opens down. Next, we're going to write the equation of a given parabola in vertex form. So the first thing we need is the vertex. In our case, our vertex is 3, -2. We're going to substitute that into the generic function for vertex form for h and k. Remember, the 3 goes into the asylum, becomes opposite. The k stays outside and is normal. What we don't know is a, so we're going to take this other point on the graph, put that in for x and y to solve for a. Our y was 0, and our x is 5. Simplifying that right-hand side, 5 minus 3 is 2. 2 squared is 4, so we have 4 times a minus 2 will equal 0. Adding 2 to both sides and dividing by 4 gives us an a value of 1/2. Putting that back into the function with the vertex, we would get y equals 1/2 x minus 3 for that x-coordinate of the vertex, squared for the parabola, minus 2 for the y-coordinate of the vertex. Finally, looking at domain and range, it is a quadratic function, so domain is all real numbers. Range, it opens up, so y is greater than or equal to the y-coordinate of the vertex. Looking at that one more time, this time our vertex is -1, 4. Subbing that into the generic equation. The -1 goes inside and becomes positive. The positive 4 is outside and stays positive. And then we're going to take that 1, 3 and sub them in for x and y. The 1 was the x-coordinate and the 3 is the y-coordinate. Solving for a, on the right-hand side, we have 1 plus 1 is 2. 2 squared is 4. Subtracting 4 from each side and dividing by 4. Notice our a value is negative and the graph opens down, so that makes sense. Subbing that value back in, the -1/4 for a, the x plus 1 for the x-coordinate of the vertex, plus 4 for the y-coordinate of the vertex. Finally, domain and range. It is a quadratic function, so the domain is all real numbers. The range, it opens down, so y is less than or equal to the y-coordinate of the vertex.